Adenosine triphosphate, commonly known as ATP, is a universal and immediate usable form of energy for all work performed by any cell within the body. ATP consists of one adenosine molecule and three phosphate molecules. Energy is created when one of the phosphate molecules breaks off, allowing the body's cells to perform work. The human body uses three different energy systems to provide the body with necessary amount of ATP for different activities. The three energy systems used in the human body are the ATP-CP system, the lactic acid system, and the aerobic system. The ATP-CP energy system is used for immediate energy in any maximal effort less than 10 seconds and uses creatine phosphate for fuel. The lactic acid system is used for fast energy in any high intensity effort and uses glycogen for fuel. The aerobic system is used for slow energy in moderate to low intensity efforts and uses glycogen and triglycerides for fuel. Whether we are resting or engaging in exercise, all three energy systems are active simultaneously. The duration and intensity of the activity determine which energy system is most dominant at any particular time. In this task, I will analyse the physiological demands of an elite level and amateur touch football game, specifically focusing on the middle and wing positions. My goal is to analyse and evaluate the differences in the interplay of energy systems unique to each position. This exploration aims to provide a comprehensive understanding of the physical demands at play in touch football, which can provide insights for optimising personal performance in both middle and wing positions for the future. Peter Norman is an Australian touch football player who plays the middle position. The middle position in touch is well known to have the most consistent and fittest players playing the position. Before the match whistle is blown, Norman's body is working aerobically. This is due to his body receiving enough oxygen for the current exercise demands. As the game starts, Norman's exercise intensity increases, leading his body to use the ATP-CP energy system as its dominant. Because Norman's body has insufficient oxygen to meet the increased exercise intensity, his body enters an oxygen deficit. An oxygen deficit is a period when the aerobic system desperately tries to catch up to the oxygen demand on the body. Because of the oxygen deficit, Norman's body can't work aerobically. This leads to him using anaerobic pathways until he has sufficient amount of oxygen to fuel the aerobic energy system. At the 6-second mark of the game, Norman bursts off the defensive line to get a defensive touch, and by the first 10 seconds of the game, Norman's creatine phosphate stores began to deplete rapidly due to repeated high-intensity bursts. At this point in time, Norman has undergone 6 seconds of maximal work, and his energy system contribution is approximately 57.5% ATP-CP, 40% lactic acid system, and 2.5% aerobic system. As Australia gains possession and Norman actively contributes to driving the ball up the field, he engages in 3 passes and executes 1 roll ball. These explosive efforts almost completely deplete his creatine phosphate stores, prompting his body to rely on glycogen stores and shift to the lactic acid system as the primary source of energy. The onset of blood lactate accumulation, known as obla, becomes evident, leading Norman's muscle to fatigue, thereby impacting his overall performance. Obla is a point during exercise when the production of lactate in an athlete's muscles increases to a point where the production is faster than the rate of removal. As Norman continues his high-intensity activity, the accumulation of lactate reaches a level where it starts impacting his muscles, causing fatigue. This fatigue affects Norman's overall performance, making it harder for him to sustain the same level of effort. Recognizing the need for recovery, Norman strategically takes a break during the early stage of the match. During this time, Norman's body enters excess post-exercise oxygen consumption, also known as EPOC. EPOC plays a crucial role in replenishing creatine phosphate stores and removing accumulated blood lactate. Over the course of the match, Norman comes off the field 12 times, with an average rest time of 2 minutes and 13 seconds. This means, on average, Norman was recovering approximately 93% of creatine phosphate stores every time he had a rest, which ensures when Norman is on the field, he can work at a high intensity. It is shown that an active recovery would have the most benefit to Norman due to its ability to lower blood lactic acid levels faster than a passive recovery. Sean Francis is an Australian touch football player who plays the wing position. The wingers on the team are usually the fastest players on the field because they cover a large part of the width of the field. Before the game starts, Francis' body is working aerobically just like Norman's. This is due to his body receiving enough oxygen for the current exercise demands. Francis begins the game bursting out the line of defence to get a defensive touch. This shifts his body to move from the aerobic system to the ATP-CP energy system as its dominant. Because Francis' body has insufficient oxygen to meet increased exercise intensity, his body also enters an oxygen deficit. Although compared to Norman's oxygen deficit, Francis' is a lot shorter and less harsh. This is due to the low intensity nature of Francis' position. This means that Francis' body can return to its aerobic energy system as its dominant a lot faster than Norman's does. Francis then continues the game working at a low intensity. Because Francis works a lot of the game at a low intensity, It acts as an active recovery which allows his CP stores to resynthesize and his aerobic energy system to thrive. All of this creatine phosphate he says working aerobically, he can use whenever he is called on. This is shown in the second half when Francis is called upon to make a high intensity defensive touch to stop the opposing offense to score a try. To pull off this touch, Francis's body got an immediate burst from his ATP-CP system to provide it the additional energy needed to make this touch. During this time, Francis's body entered another oxygen deficit due to the insufficient oxygen to meet the increased exercise intensity. Because Francis's position only involves short duration bursts every so often, it allows Francis to stay on the field for longer periods of time. This is proven when looking at the substitute statistics. Throughout the game, Francis comes off the field a total of 4 times compared to Norman's 12. This shows the difference in position and the different roles each player plays on the field. This also means that when playing the middle position, you reach your obula a lot faster and a lot easier compared to playing the winger. This is due to the middle position doing a significant amount more high intensity repeated efforts and being more involved, which means they rely on the lactic acid system for energy a lot more than the winger. Although the winger has high intensity bursts similar to the middle, they spend a lot of time at a low intensity which allows their body to get rid of the hydrogen ions and inorganic phosphates. This leads to the middle needing far more breaks more often compared to the winger to allow for the repetitive high intensity bursts while on the field. To get a better understanding on the interplay of energy systems in touch football, a Year 12 physical education class played 2 games of touch football. Although the Australia vs New Zealand game was played at a much higher level in both skill and intensity, similar patterns still appeared in our amateur game when playing the middle and winger positions. Before I came onto the field in the first game, my body was working aerobically. This is due to my body receiving enough oxygen for the current exercise demands. When I first get onto the field, in the middle position, my dominant energy system instantly shifts from the aerobic energy system to the ATP-CP energy system when I start driving the ball up the field. Because my body didn't have enough oxygen to meet the increased exercise intensity, my body entered an oxygen deficit similar to Norman's. The continued high intensity efforts when driving the ball up the field, as well as working on defense getting defensive touches, rendered the lactic acid system was heavily relied upon. The heavy reliance on the lactic acid system when playing the middle position led to fatiguing factors all throughout my body. Instead of going to the bench for a rest to resynthesize my CP stores and flush out any lactate from my blood, I decided it would be a good idea to play the winger position for a rest, as there were not enough substitute players for frequent rest periods. This is due to the low intensity profile of the winger position, which acted as an active recovery. Whilst playing the winger position, I used far less energy compared to the middle. This is shown in the data profile as I averaged far less touches playing the winger position compared to the middle. The low intensity nature whilst playing the winger position allowed for resynthesis of CP stores, which allowed for high intensity bursts when called upon. This is shown in the first half when I went from a low intensity walk to a high intensity sprint, catch and try. The interplay of energy systems also made apparent when looking at my heart rate data. When playing the middle and winger positions, my heart rate was both at an average of 160 beats per minute plus. However, when playing the middle, it was constant. This was due to the high intensity repeated efforts. While playing the winger position, my heart rate wasn't a constant and varied up and down. This is due to the low intensity efforts, as well as the high intensity bursts required when playing the wing position. A consequence of playing the middle position was the need to substitute often. However, this was not shown in the amateur game, as I only had 2 rest periods off the field for the entire game. This meant that due to the heavy use of the lactic acid system, I couldn't maintain a high intensity for a sustained period of time, which was detrimental to my overall performance. In conclusion, the analysis of elite and amateur touch football players in the middle and wing position shows the difference between the interplay of energy systems between each position and skill level.